Hello everyone, welcome to video lecture on magic methods in Python. Oops. Myself Ajay Dhulkhedkar, Assistant Professor, Department of Electronics and Telecommunication, Walchand Institute of Technology, Solapur. Learning outcome of this video lecture. At the end of this session, student will be able to explain magic or dunder methods in Python object oriented programming system. So what are magic methods? Magic methods are special methods or built-in methods in Python. As we know, everything in a Python is designed in the form of class and objects. For example, if you want to declare some integer variable or if you want to create some integer variables, you can assign integer value. Based on assigned value, Python interpreter will understand it is integer type of object which must be created in a memory, and after that you can use some built-in methods like you can print the integer value or you can perform some arithmetical and logical operations on integer value. Based on the operator and based on the built-in function, Python interpreter will understand it has to perform some arithmetic operation or for example, if you use plus operator and if you provide two operands, Python will understand it has to perform addition on integer operation. So based on if you want to create some classes for other data type, we in this example or in this video lecture we are going to write or we are going to create the class for fraction addition or class for fraction data type. Based on which we are going to perform some arithmetical operation and built-in function we will use print method to print the fraction type of data. So basically some examples are given for the magic methods. So magic methods are basically built-in methods in a Python which are denoted by 2 underscore at the start and 2 underscore after the end. Here some examples are given. For plus operator, there is a built-in addition method underscore underscore add underscore underscore. Instead of print, to use print, there is a underscore underscore string underscore underscore method is built-in method, that is magic method, and for the equality operator there is a equality built-in method. Why to use magic method? To make custom classes behave like built-in classes. As I told, to make custom classes like integer data type, you designed some fraction class, so object created by the fraction class must behave like built-in class like integer, float or string. So you can, whenever you want to perform addition between two objects which are created by user defined class, if you create fraction class and f1, like for example f1 and f2, like two objects are created, so if you use plus operator between these two objects, so Python interpreter will understand it has to perform some operation based on the operator. It will access by default magic method, addition method, and based on whatever logic written under addition method, it will perform the operation and it will return the output with given example. So creating a fraction class, first to simplify fractions we are using GCD, which is already written, or we are going to import GCD. So first statement is from math import GCD, and here fraction class has been declared. So after declaration of fraction class, init method has been written. Init method is nothing but constructor method. So whatever written under the init method, whenever you are going to create object from this fraction class, the code written under init method will execute automatically. So it has two arguments. Self is by default argument. Other than self, it has two arguments. One is numerator and denominator. As we know, fraction has two parts. One is numerator part and another is denominator part. So self is reference to the current object. When you are going to create object using this fraction class, self will contain the reference for the class current reference for the object which has been created by the class name. So first condition is checked whether denominator is 0. If denominator is 0, the error is raised, denominator cannot be 0. So GCD has been calculated by user provided arguments, say numerator and denominator. So common value is used to simplify the fraction expression. Here example is given, fraction 2 comma 4, value 2 comma 4 has been passed to constructor method and further it will be simplified to 1:2. This is about creating an object and assigning value to an object. Next, after creating value, we will see f1 is created using 1/2 and f2 will be created 1/3, and for f1 constructor has been called once and for f2 constructor has been called once. When you use addition operator for f1 plus f2, that is two objects are added here, the result must be calculated like 5/6. So automatically Python interpreter will understand it has to call addition method, which is magic method. This definition is already written in a Python interpreter in Python language. Only we are using this logic has been written by the user. Only we are calling this function and we are writing the logic. Whenever we call using plus operator, if you perform addition using plus operator between two objects, it will understand it has to call the dunder method or a magic method, which is written in a fraction class. This method must be written under the fraction class. After calling this method, addition method, the first argument for addition method is reference of this f1 object, which will be stored in a self, and second argument for this addition method is f2, reference for f2 object, which will be stored in a other object. So we have two operand for the addition. To access numerator value of f1, we will use self reference. To access numerator and denominator value of f2, we will use other reference. So how to calculate, how to perform addition of fraction values? The cross multiplication has been done. Self dot numerator into other dot denominator plus other dot numerator into self dot denominator. Likewise, the numerator value of result will be calculated. Likewise, self dot denominator into other dot denominator, the denominator value of result will be calculated. So this function, the final statement of this function is return fraction, new number and new denominator. Again, this will return one object. This method will return one object which will have one numerator value and which will have one denominator value. Again, the constructor for this object will be called, and finally we will get fraction object for the result of this addition operation. Likewise, we can perform subtraction. Again, subtraction is also binary operator. For subtraction, we will need at least two objects. So two objects has been created, like first object is f1 is equal to 3/4. While creating this f1 object, constructor will be called and final value 3/4 will be stored in this object, f1 object. And f2 object, while creating f2 object, the constructor has been called with the argument 1, 2 and finally 1/2 fraction data will be stored in a f2 object. Or will be performed subtraction operation and will display the result using print command. So after calling or after using this minus operator, Python interpreter will understand it has to call subtract magic method, which is already provided by Python interpreter. Only difference is logic is written by the user. We are going to write this logic to perform subtraction between two objects. So this is about subtraction operation. Likewise, we can perform multiplication operation. So logic for the multiplication has been written under the magic method multiplication. So we have performed the addition, subtraction. Here logic for the multiplication has been written and the result is transferred to the constructor to create a new object which is result of multiplication. For example, here we printed the multiplication of two objects, fraction objects, 2 by 3 into 3 by 4. Numerator into numerator and denominator has been calculated and created a new object which has the value, result value 1 by 2. Next, we are going to use another operator which is equality operator. Whenever the equality operator between two objects used, a Python interpreter will understand it has to call equality magic method. So whatever business logic written under equality operator, that logic will be executed and result will be calculated according to the logic. Our first part is stored in a self and reference for other part, F2 part is stored in a other object. So self will access numerator part of first fraction number, other will access numerator part and denominator part of F2 fractional number, other fraction number. So if both are equal, then result will be written in the form of boolean value. If both are equal, true is written. If both are not equal, then false is written. So 2 by 4 equal to 1 by 2. If you simplify 2 by 4 further using GCD, it will generate a result 1 by 2. 1 by 2 equal to 1 by 2. So result will be true. This is the final code. We imported GCD. We declared a class fraction and constructor method has been written to whenever we are going to create object using this fraction class, automatically constructor method will be called. Based on we will get the value numerator by denominator. Likewise, there is another magic method which is used to display the value which is stored in the object. If you print object F1, any object created using this fraction class, whatever written under str magic method, that will be displayed. Here str returns f string self.numerator self.denominator. Here addition method, multiplication method, here addition method, multiplication method, equality method has been written. So for example, we have declared F1 and F2 two fraction numbers. Based on we are going to print value stored in F1, value stored in F2, and we are going to print addition operation between F1 and F2. We are going to print subtraction operation between F1 minus F2 and multiplication operation between F1 and F2. The result will be displayed. So whenever we are going to use operators to perform operation between objects created by user defined class, we will get these output. These output are calculated from these functions, which are nothing but magic methods or dunder methods which are used in a Python. Thank you.